Every Valentine's Day, people send each other hundreds of millions of cards. In the US alone, 145 million, and every single one carries the same symbol, the heart symbol. Not one of them looks like the real thing. This is your actual heart. Asymmetrical, cone-shaped, tilted to the left, nothing like the symbol. So why does the most recognizable love symbol in the world look nothing like the organ it represents? This is never a coincidence. Two separate paths, one cultural, one biological, ran in parallel for over 2,000 years. They never crossed, and they never will, okay? We're tracing both. About 2,600 years ago, on the coast of what is now Libya, there was a city called Cyrene. There, a plant called silphium was grown, like a giant relative of fennel. It was so valuable that it held up the entire economy. It was used as a spice, as medicine, and even as birth control. On coins minted between 650 and 300 years before the Common Era, the silphium seed appears in a shape strikingly similar to the modern heart symbol. But when this matters, this is only a theory. Historians see the resemblance, or no one can prove this is where the symbol began. Here's what we do know is this. A plant tied to love and fertility was stamped onto coins across the Mediterranean in a shape that looks familiar to us today. The plant went extinct, likely from overharvesting. The shape may have lingered in visual memory, or it may not have. We simply don't know. Let's move to medieval Europe. The first image of a heart outside of anatomy books appears in the 13th century. It's in a French manuscript called The Romance of the Poor, painted in Paris around the year 1255. Before that, artists drew it like a pine cone. They were following the descriptions of Galen, the Greek physician, and his writings had produced this exact shape. The twin-lobed shape we recognize today came later, in the late 14th century, in France and the Low Countries. This wasn't the work of doctors, it was poets and painters reshaping a symbol through art. By the 1300s, the heart symbol had found its way into love poetry. Guillaume de Machaut used it. His ballad, Love Makes Me Desire, still survives today. Machaut turned the heart into the language of emotion itself. By the 15th century, it had become a suit on playing cards. Millions of people held the symbol in their hands without ever opening an anatomy textbook. Then in 1530, Martin Luther placed the heart at the very center of his theology in a letter to Lazarus Spengler written on July 8th and documented in his collected works. He described a black cross inside a heart. The symbol had become powerful enough to carry an entire religious revolution. None of this on the coins, the poems, the cards, the seal, it was inspired by looking at a real heart. Culture built this shape. Anatomy had nothing to do with it. So what is the real heart then? Roughly 300 grams, about the size of a fist. It beats 60 to 100 times per minute, centered in the chest, tilted to the left, not red, not symmetrical, a dense asymmetrical muscle built for one purpose, efficiency, 4 chambers, 2 upper atria, 2 lower ventricles, 2 pumps sitting side by side. The right side takes blood low in oxygen from the body and sends it to the lungs. The left side takes oxygen-rich blood from the lungs and pumps it out to the body. Separate, no mixing. This separation is the foundation of everything. And here's where it gets interesting. Over millions of years, the hearts of vertebrates changed. Fish have 2 chambers. Amphibians have 3. Mammals and birds have 4. Why 4? Oxygen efficiency. Keeping oxygen-rich and oxygen-poor blood completely separate means tissues receive blood with a much higher oxygen concentration. Well, frogs' 3-chambered heart allows some mixing, and the evidence suggests This works fine for a cold-blooded animal with low metabolic demands, but mammals and birds are warm-blooded with metabolic rates far higher. That demand favored complete separation, more oxygen, a more stable internal temperature, and researchers argue that the conditions that made larger brains and more complex behavior possible. And it runs on electricity. The SA node or sinoatrial node sits in the wall of the right atrium. It fires 60 to 100 times per minute. The signal travels to the AV node, slows down briefly, and then spreads into the ventricles. Why the delay? So the atria can fully empty before the ventricles contract. The heart isn't just a pump, it's an electrical system that times itself. One last detail, the heart feeds itself first. The coronary arteries branch directly off the aorta, the body's largest blood vessel. The very first branches off that main line go straight to the heart muscle itself. For 2,000 years, these two things ran on parallel tracks. On one side, a symbol shaped by culture, a plant on ancient coins, poets in search of metaphors, card makers, and religious reformers. No doctor ever drew the heart symbol because it looked accurate. On the other side, a machine shaped by biology, driven by oxygen demand and millions of years of vertebrate evolution, solving exactly one problem: keeping a warm, active body alive. One is a metaphor, the other is a machine. Almost nothing connects them, not their shape, not their origin, not their purpose. As the heart symbol spread through medieval art, accuracy was never the goal. It became the language of romance and faith, not observation. No doctor ever drew the heart symbol. No poet ever wrote about coronary arteries. Two lines running for thousands of years, never once crossing, and that's the point. The most famous symbol in history was never designed to show what it claims to represent. The heart symbol on your phone probably started as the seed pod of a plant that no longer exists. It traveled through poetry, through playing cards, through theology, and ended up as an emoji. The real heart is roughly 300 grams, has 4 chambers, triggers its own beat, and was shaped by hundreds of millions of years of evolution to keep warm-blooded animals alive. One was shaped by human feeling. The other was shaped by biological necessity. At MedClarity, we look at the things that you think you already understand, and we find the science underneath them. And here's our next question. Why does your brain run on its own internal clock? And what happens when it gets thrown off? We'll break down the science of sleep and the circadian rhythm. See you next time.